Hello everyone. My name is Jifeng San, and welcome to my paper presentation for course CS 6263. And my topic for the paper is, Hey Alexa, is this skill safe? Taking a closer look at the Alexa skill ecosystem. So this paper was originally presented at the Network and Distributed System Security Symposium in 2021. So first of all, just give you a very brief introduction about Alexa. Alexa is an intelligent personal assistant developed by Amazon, and it is made popular by the Amazon Echo or Amazon Echo Dot devices developed by Amazon. They are able to have a voice interaction, and they are able to um, do a music playback, provide real-time information, and even control smart devices in your house. And they can do more about this stuff. So here is a workflow of the Alexa interacting with a user. So basically, a user send a request, typically verbally. So this is so-called invocation name. And in this example, for example, Alexa open daily code, and this Echo device will forward the recorded audio stream to the Alexa skill interface, which is in the Amazon cloud service. And then they generate a intent. This intent can be resolved by the cloud service and further forwarded to the third-party skill applications. So this intent in this example is just a daily code intent. Then the third party will treat this intent and send back a function or skill application, then back to the end user. So the goal of the paper is to systematically analyze the Alexa skill ecosystem to identify potential problems, potential loopholes that can be exploited by malicious actors. So to achieve this goal, they propose three research questions. So the first research question is, what limitations exist in the current skill vetting process? And to address this question, they studied the following 4 points, so such as duplicate invocation names, developer names, registered intents, permission model. And the second research question is, how effective are skill squatting attacks, such as which patterns are more effective? And the third question is the requirement of providing a privacy policy link effective? Such as whether privacy policies serve their purpose. So comparing to previous study, this paper actually studied all these aspects compared to other papers as shown in this table. So the first step is to collect skill data. So what the author did was they collected data from Alexa skill stores across 7 countries: United States, United Kingdom, Australia, Canada, Germany, Japan, and France. And on the right, this table summarizes the number of skills collected from these 7 different stores. In total, there are 1,507 150,700 more than 700 skills, and among them actually about 90,194 skills, they are unique skills, and also about 24% of the skills provide a privacy policy link, as summarized here. And table 3 shows the number of developers indicated by the orange colors, and the number of skills in the bottom half indicated by the blue colors, shared between different stores. The diagonal bold numbers represent number of skills and developers only available to those specific stores. So, for example, Australia and Canada, they are sharing 7,634 developers. But in this table, you can see that each store has its own set of unique developers and skills. So to address research question 1, which is what limitations exist in the current skill vetting process. So the first aspect they study is this duplicate skill invocation names. So basically, how Alexa selects a skill among skills with the same names. So the left figure shows the distribution of skills with the same invocation names across different stores. So we can see most of the skills, they share invocation name, because on the X, you can see on the X axis, basically the number of skills per invocation is larger than 1 for almost every distinct invocation. So this indicates that more than one skills they're sharing the this invocation name. Well, the issue or the problem here is that the method for how Alexa prioritizes among skills sharing the same invocation name is not available to the public. And in this paper, they specifically selected several skill attributes. Then they try to correlate those attributes with how Amazon prioritizes skills with the same invocation name. So here in this table, as you can see, in attribute 1, there are 4 specific attributes. So they have different number of ratings, different average rating, age of skill, and content advisory. So in this specific experiment, they studied 50 skill pairs. Then they noticed that so the results show that the odds ratio for number of ratings is the highest attribute, which has a favored attribute with more ratings. So this simply means the number of ratings, the more the number of ratings, the higher the odds ratio. Or so this 16 means it has 16 higher possibility that can be activated compared to other the other skills. So this study simply means that the higher number of ratings or the higher average ratings, they tend to have higher possibility to be activated for the skills. And in the meantime, the age of skill, so basically how long is the skill distributed in Amazon, and the content advisory, these two attributes don't really have a big influence on the skill activation. So since they know that number of ratings is an important attribute, so the second study they conducted is keep the number of ratings the same. Then they are studying the effects of the other 3 attributes. So they notice that again, this average rating still shows higher odds ratio. So the first finding in their study for addressing research question 1 is that due to the lack of transparency on how Amazon auto-enables skills with duplicate invocation names, users can easily activate the wrong skill. So While there is a positive correlation between a skill being activated and the number of ratings it receives, it doesn't imply causation. Then the second aspect for the first research question they studied is to investigate the registering using well-known developer names. This is because currently developers can register themselves with any company name when creating their developers account with Amazon. So there is no strict checking um, on this part. And here shows the examples how they conducted this experiment. The left figure, this figure A, is a native skill by Amazon. Then the authors try to set up account using Ring as the developer, so they can successfully set up the account, and Amazon actually links this skill the author set up to the products by Ring. So you can see there's a limitation in this aspect. So the second finding is that an attacker can get away with publishing skills using well-known company names, and this primarily happens because Amazon currently does not employ any automated approach to detect infringements for the use of third-party trademarks. And the third aspect is to test the code change after approval. This is because currently there is no restriction that is imposed on changing the backend code, which can change anytime after the certification process. So, for example, on the right, how an attacker can exploit this gap. Basically, first of all, the attacker follows all the general steps from step 1 to 3 to register a skill. Then in this skill they can insert an intent that remain dormant, and after this skill is published, the attacker then changes the backend logic to cause the user to invoke the dormant intent, which may correspond to some form of sensitive information such as phone numbers, following these steps from 4 to 6. So the third finding here is that an attacker can make code changes after approval to coax a user into revealing sensitive information. And the fourth point here is bypassing the permission model. Well, now skill developers can avoid requesting permissions to access personal data by simply requesting the personal data through verbal interactions. And in this table, it summarizes the detailed breakdown of skills potentially bypassing the Alexa permission model. So in this study, the authors summarize the skills in terms of 4 data types: name, email, phone, and location. And after manually inspecting skill description, they found 358 unique skills. And among these skills, there are 169 skills that do not provide privacy policies link. And so then they conducted the activation of the skills of those 358 skills, and they find that a total of 166 skills request data verbally, and so they request the data type are mainly focusing on name and location. And again, it's almost is 99. There are 99 skills. This request they don't provide privacy policy links. So the first finding is that Alexa does not properly mediate the intent of sensitive data types, as demonstrated above. An advisory can directly request data types that are structured to be protected by permissions APIs. Then for the research question 2, which is how effective are skill squatting attacks? The first aspect they studied is these common approaches for squatting skills. So they try to study phonologically similarity between invocation names. On the right, this figure shows the similarity score for invocation names taken from all English-speaking stores, and they apply different methods and algorithm to study the train. But basically, you can see this method have pretty similar trains. So basically, a higher percentage of invocation pairs correspond to higher similarity. And in order to treat the, to study the potential squatting attempts, so those invocation pairs with an average similarity score larger than 0.93 are marked as potential attempts. And then they further study the 4 common skill squatting patterns, which are homophones, punctuation, spacing, and different spellings, including spelling mistakes. So summarizing this table, those are the 4 common skill squatting patterns based on the analysis of phonetically similar invocation innovation names. So basically, you can see 2 of them, like homophone and the spelling, are the main patterns that occur. And here there are also some examples for each pattern. So the 5th finding is that while we find 4 common approaches for squatting an existing skill, the authors they didn't actually find any systematic malicious abuse of skill squatting in the wild. And the second aspect for the second research question is the efficacy of skill squatting. Again, they choose from they choose 10 skill pairs using the 3 common spelling 3 common skill squatting patterns summarized in this table. Basically, they choose spelling variants, punctuation, and homophones. So there are 30 pairs in total. Then they selected these 30 pairs innovation pairs then studied the efficacy of skill squatting. And what they found is that certain approaches within each skill squatting pattern have a higher likelihood of successfully squatting skills. For example, correct or accepted spelling increase the likelihood of launching the expected skill. And on the other hand, for punctuation, appropriate usage reduced its change of being activated. And then for the third research question, is the requirement of providing a privacy policy link effective? So to address this question, we first look at the availability of privacy policies. So summarizing in the right table here shows the number of skills per category in the US store, along with the percentage of skills that have a privacy policy. So we can see, so first of all, Amazon does not mandate a privacy policy for all skills, rather only for skills that request access to one or more of their permissioned APIs. So on the right table, we can see in general, about 28.5% of the US skills provide a privacy policy link. And based on different categories, we can see that the number of percentage number of skills with privacy policy can be quite different. And you can see, for example, for smart home is more than 93% of the skills, they provide the privacy policy link. But on the other hand, for the kids category, we only have 13.6% of skills with privacy policy. This is a little surprising, which is also the main finding of this aspect, because as we show in the US skill store, there is only 13.6 of skills belonging to kids category. This should be held to higher standard with respect to data privacy, according to the research, the study of the authors in the paper. Then the authors also studied the efficacy of privacy policy requirement. So here are the results of the number of skills that request specific permissions by store category. So let's look at the table first. So in this table, we can see, so first of all, notification and reminders, these two permissions do not mandate a privacy policy link. So you can see the number of skills without a privacy policy link are much higher compared to other permissions. If you compare the numbers in the parentheses. But you also see that we still see some missing privacy policy links in several of the other permissions. And on the right, in this figure, we can see, so this shows the correlations, relationships between category permissions and the different permissions and the skills without, the skills request specific permissions. So you can see, for example, in for music and audio category, this category actually request this specific postal code permission quite much. Has more than 200 requests focusing in this category and permissions. So the finding here is that about 90% of the US skills requesting one or more permissions actually provide a valid privacy policy, even though we see some missing privacy policy links. But more than 90% of the US skills, they have a valid privacy policy. And again, for the advocacy of the privacy policy requirement, they also study whether the privacy policies address the permissions requested. So basically, this is a permission to policy consistent analysis. On the right, that's the result for this analysis. So in the paper, the author summarized that in this analysis, in total, only 76.7% of the privacy policies completely addressed all of their requested permissions, and specifically, if we look at the full name permission, about 33.1% of skills requesting full name permission did not disclose the collection of such data in their privacy policies, indicated by this red color. So that's 41 request, 41 skills. So the finding corresponding to this part is that, so again, around 23.3 of the privacy policies are not fully disclosing the data types associated with permissions requested by the skill, and the many skills in the full-time permission category did not disclose the collection of such data in their privacy policy. And in the meantime, the author also found that two widely used privacy policy templates were resulting in 74 permission to policy inconsistencies across 46 skills. So this corresponds to the tenth finding, which is that privacy policy templates result in potential regulatory non-compliance. So to summarize, so the authors did a comprehensive, broad analysis of the Alexa skill ecosystem, and they successfully find several gaps or limitations in the skill writing process that can be exploited. And the common skill squatting techniques exist in this current study, but no systematic abuse. And they also find that inconsistency permission to policy in privacy policies for some skills. And then the author proposed several recommendations. So first of all is this skill type indicator. So specifically, Alexa could provide some form of visual or verbal indicator, such as light or different voice template when interacting with a third-party application. This will be helpful for the end user to know which skill type they are interacting with when they just request send a request with verbally with an invocation name. And second recommendation is validating developers. So Amazon could potentially utilize developer information to validate or flag trademark infringements. And the third recommendation is backend validation recurring. So potentially random recurring backend checks can be performed by Amazon. The last recommendation is privacy policy template. So this simply asks developers to fill out a simple policy template that will include details of the collected data. I think that's all I have for my presentation. Thank you for your attention, and I'll be looking forward to your questions. Thank you.